everyone, for this video we're going to talk about the second internal test paper. For the first question we had write algorithm for decision tree induction. So the first step is to check if all the tuples have the same class. We have to check if the tuples are what like that in the first internal we had some yes and no tuples. There were nine tuples for yes and five tuples for no. You can see that both the tuples were in the same class. The class was Bayes computer. So if all the tuples in the data set belong to the same class, we have to firstly create a leaf node labeled with the class C. Okay. Then this serves as a stopping condition when all the tuples in a branch belong to the same class. Okay. So as it is a stopping condition that all the tuples that we are taking for making of our decision tree should belong to the same class, because obviously if we go for a different tuple, it might not work out. Okay, so next, if the attribute list is empty, if you have to check that if the attribute list is empty, if the list is empty, we have to firstly create a leaf node neighbor labeled with majority class in D. Okay, so this is another stopping condition, so that the tree that we are making does not grows indefinitely. Next, obviously we have done all the checking process, that we have checked if the tuples are in the same class or not, if the attribute is list is empty. So after doing that, we can finally go for our next step, which is attribute selection. And how can we do that? We can do that by information gain and engine index. In the last video, we have talked about it. So both the things, information gain and Gini index, would help us in selecting criterias and to get our node, our splitting criterion. We had age as our splitting criterion in both the selection methods. Okay, and so we could finally label our current node n through these selection method. Okay, so after, if the splitting attribute is discrete valued and multi-split are allowed. Okay, so not they are multi-way splits can be done if it is a discrete value. Update the attribute list by removing the splitting attribute. So we have to update the attribute list by removing the splitting attribute. For each outcome j of the splitting criterion, partition the tuples into subsets. Obviously, we what did we do? We partitioned the tuples. We had yes and no for every value. Okay, we had for young, we had for middle aged, we have for senior. For every value, we had our tuple. So we created those subset. And after doing that, if the DJ is empty, okay, the subset are empty, attach a leaf node label with majority class in n to node. If it is empty, then we would just attach to the leaf node, attach a leaf node. Otherwise, recursively call the generate decision tree function on DJ with the updated attribute list. Attach the resulting subtree to the node n. Okay, so if it is not empty, then we would just simply go and recursively call the decision tree function, and then finally, when we have created the subtree, we can attach it to the node n. After processing all outcome of the splitting criterion, we have to return to the node n, which was age. So every other leaf node, after doing all the things, we just have to return to our node, the splitting node. Next, what is the attribute selection major? Explain three of them. So we had majorly three attribute selection, which is random selection, information gain, and Gini index. In random selection, we select all the features, any feature, we just select it randomly, regardless of the condition, if it matches all our data set or not. We do not we are not concerned with that. We just randomly select any feature that we find. They are picked on various measures. This also means they are very inaccurate. I mean, if you are just taking up some attribute, it might not lead us to our splitting criteria. It won't give us a accurate representation of our data set. So it has to be inaccurate in comparison to every other approach. For the next one, we have information gain. Information gain is commonly used in decision trees such as ID3 and C4.5. It assists the effectiveness of feature in reducing uncertainty. Okay, so it reduces the uncertainty in our data set, so that it is based on the concept of entropy, which measure the impurity or disorder in a set of data. Okay, so we have some impurities that we need to clear out from our data set, and to do that, we use information gain. For next, we have Gini index. Gini index is commonly used in decision tree algorithms such as KART, which is CART, classification and regression tree. It measures the impurity of a set of instances by calculating the probability of misclassifying an instance randomly chosen according to the distribution of class labels. Next, we have define and mathematically expression of information gain, Gini index, and reduction in impurity. So we have already talked about information gain, Gini index in the last question. Information gain, again we can do that. Information gain measures the effectiveness of feature to in reducing the impurity about a class label, and it can be done by expected information uh, formula, which we have used in the last video during while solving the question, which was pi log 2 of pi in summation. Then we had Gini index. Gini index measures the impurity of a set of instances, indicating the probability of misclassifying instances randomly chosen according to the distribution of class variables. Okay, so again we know what the Gini index was, and so it can be achieved through this way, which is through the uh, I'm sorry, uh, formula, which is 1 minus summation of pi whole square. So what is pi? Pi is the probability of an instances belonging to the class I. Okay. Next, we have reduction in impurity. So reduction in impurity is the amount by which impurity in a data set is reduced by splitting it based on the particular feature. So we had impurities when we talk about information gain. We have impurities in it, and so it removes that, so that that reduction of those impurity in a data set by when we you by doing the splitting. I mean, we do splitting, we have a splitting criteria, right? So through when we reduce it by those splitting terms in it's based on a particular feature. Okay, so that this was reduction in impurity. Next, we have overfitting and tree pruning. Overfitting occurs when a machine learning model learns the training data too well, capture noises and random fluctuation in the rather than underlying patterns. As a result, the overfit well but fails to generalize generalize to the new unseen data. Okay, so when overfitting occurs, when like you have a data set for a very long time, and now your machine knows it very well. I mean, you have given that trainings data, and how with time it got to learn it more efficiently. It has captured all the noise, all the random fluctuation in the data, rather than those patterns that we need, the patterns, the trends that we need for the new ones. Okay, so now when we give it another training set, which is a new one, it cannot it would not work, because now it can't it would just have those noise and random fluctuation. It would not take generalize our new unseen data unseen data. So overfitting is a very common issue, especially in complex models with a large number of parameters, because there are many more parameters and many features. So it is a very common issue when it comes to large models. So causes of overfitting, it could be model complexity. After it, obviously model, if it's like neural networks or clustering. So these all these models are complex because they have a large number of parameters. So yes, it could cause some sort of overfitting. Then if there is a insufficient data, I mean there are some missing values, or it could be that for some of them could be in different ways. Okay, that could be written in different ways. Okay, but the format of the data is not similar for two records. In that way, it could be insufficient and noise. There could be noise in the data. Next, we have tree pruning. Tree pruning is a technique used in the decision tree algorithm to reduce the size of a tree by removing branches that do not contribute significantly to its predictive power. Pruning helps in preventing overfitting and promotes the creation of simpler and more interpretable trees. So, tree pruning is our cure for overfitting. Okay, so it tries to reduce the size of the tree by removing all those branches which are not required right now, which are not significant in in, uh, in the impact right now. I mean, the final result that we need, it does not significantly contribute to that. This way, the overfitting could be prevented, and so that we could promote or make simpler and more interpretable trees. Pruning is a crucial step in decision tree construction to achieve a balance between complexity and accuracy, ensuring that the tree capture essential parts without memorizing noise in the training data. Benefits of pruning: improved generalization. Pruning reduces overfitting and improves the model's ability to generalize to new data. Simplicity. Prune trees are simpler and more interpretable, making them easier to understand. And so, for this way, we conclude the video. We had overfitting, we had tree pruning, we had information gain, Gini index, reduction and impurity. So, we are at the end of the video.